program that allows for the polling of a shared drive in the air. So as the aircraft and the system, the flash system collects 3D point cloud data that's colorized, converts it to the UDS file. As soon as the software detects on the shared drive that a new UDS file is present, it will load that file into the view and automatically pan the camera to that location. So what you're seeing here is an addition of multiple UDS files, about one every 2 seconds, 1 or 2 seconds. And this data is collected, processed, converted in real time, losing only at most about a 30th of a second of data. And then that data can be accessed from the ground or a remote base. So the orange box, sorry about that, pressed a button I shouldn't have. Let me start that over again. The orange box in both of the screens shows the extent of the newly created point cloud file. The left screen is an orthographic map view streaming in OpenStreetMaps. The right screen is a perspective 3D view. You can see the coloration of the points. You can see they're in true 3D form. We're not seeing a picture of the points or a video. It's actually the points are being streamed to the user's screen. The user can override the automatic camera zoom to function, which I'll do here in just a moment. And then the benefit of that is the ability to see all of the data that's been collected up into that moment in time. All the data for the entire mission, potentially preloaded data from previous missions, so change detection can be performed, any type of post-process analysis can be performed. I shouldn't say any type, certain types of post-processing analysis can be performed. And in this scenario, the video shows the multiple UDS files loaded on the left, but now the screen will be zoomed out. Instead of the auto tracking, we can see data being created in real time, added to the display. We'll see here just on the southeast side, there's some new data being collected. So we're panning over in 3D, and all of this is accessible from the ground in real time. The required data transfer rates are very impressive. They're about 5 megabits per second. Most full motion video data transfer connections are far higher than that. So there is technology out there. There's commercial technology, there's government, there's military technology, but the point is this is very achievable transfer rates to access these points down to the ground. It provides one other capability, is the ability to create additional products more than just the colorized point cloud. In this case, what we see here is RGB fused LiDAR point cloud. This is from our helicopter system, by the way. This is not flash, but we have a camera on board that we can run an algorithm to synthetically interpolate points in between the LiDAR points to preserve the resolution of the imagery, which is almost always higher resolution than the LiDAR. So this is a Big Thompson Canyon northwest of here, just a few days after the huge flood that occurred a few years ago. So you see the difference between the RGB fused LiDAR in the screen and the 3D image product. This can be created and processed on the fly. So it's a very impressive end product that is also in the development plans for being streamed to the ground from manned or unmanned aircraft. If you'd like more information on this, Merrick is at booth